Hi, let's continue talking about hypothesis test. In the previous video, I explained the concepts and I showed you some examples about how to come up with the null and alternative hypothesis. And doing that has consequences for the definition of the tails in the distribution, and that's very important because it has consequences for how we're going to set up the problems and solve them and determine which hypothesis is true. Okay, so these are the guidelines to help you determine which tail we're talking about. For example, if the null hypothesis has a problem or a statement of the problem in which the mean or proportion is higher or equal than something, then we have a lower left tail test. And that happens because the test is always done in the alternative hypothesis. And in this case, the alternative hypothesis has to be smaller than the number highlighted in the hypothesis. Let's take a look at one example. The label on a soft drink bottle states that it contains at least 67.6 fluid ounces. Okay, so the null hypothesis in this case is that the mean amount of fluid ounces in a bottle is equal or higher than 67.6 ounces. Is equal or higher because the bottle has at least, it can have more, but has at least 67.6 fluid ounces. Okay, so the alternative hypothesis is that the bottle has less than 67.6 ounces. So the challenge is that the bottles don't have the full amount of fluid ounces. Let me show you one example. Oops, here. Okay, so that's the null hypothesis. That's not good. Let me do it again. The mean is equal or higher than 67.6 ounces. So if I draw the distribution, let's say the mean is here and we're talking about the mean. Okay, so I believe that is higher. The challenge, which is the alternative hypothesis, says that has less than 67.6 ounces. So when we talk about a null hypothesis that is higher, the alternative hypothesis is that it is smaller. Then smaller means to this side is small than numbers, which means to the left, to the distribution. Okay, I hope it makes sense. Let's take a look at another one. If the null hypothesis says that the mean or proportion is smaller than any given number, then we have upper right tail test. Okay, that's because the test is that the alternative hypothesis is higher than the number. Okay, let's take a look at this example. The manager claims that customers buy less than $50 per store visit. So if he claims, he's not trying to prove anything, he's assuming that this is the state of affairs. So the null hypothesis is that the mean amount spent by customers is equal or less than $50. So the alternative hypothesis is that the mean is higher than 50. Okay, if the null says that is smaller or equal, the alternative is higher. Always like this. Okay, if the null says smaller or equal, the alternative says higher. If the null says smaller or equal, the alternative says higher. Okay, so it's always the opposite, and the equal sign is always on the null hypothesis, never in the alternative hypothesis. Okay, so let me show you that in here. So let me see, take some time. Okay, so we have hypothesis that says that the mean amount spent by customers is smaller than 50. The alternative hypothesis is that the mean is higher than 50. If we draw, and now I will draw an amount, I will suggest you to draw So if the mean is 50 and the alternative says that is higher, then what we are doing is we are testing that is higher, is 51, 52, 53, and so on. So this is the reason is a upper tail test. Okay. And finally, when the null hypothesis says that the null hypothesis is equal, that the mean is equal to a given number, then we have a two-tailed test. Okay, that's because the alternative hypothesis test that the mean is different than the number stated in the problem. The ABC company has a customer satisfaction equal to 4. So the null hypothesis that customer satisfaction, the mean is equal to 4. The alternative is that the mean is different than 4. Okay, so let me show you again. A null hypothesis, the mean is equal to 4. Alternative hypothesis, the mean is different than 4. Okay, so different than 4, we have a two-tailed test, because could be higher, could be smaller, and then we would test the two tails. Okay, that's the consequence of defining. And this is a summary of all these hypotheses. Let's take a look at some examples in MindTap. Okay, let me go to the MindTap, and please use MindTap a lot. Explore MindTap. Make sure that you go over the problems and practice and practice and practice, because that's the only way to succeed and learn and do good in this class. Okay, let's take a look at some problems. So if you want to find these problems, you go to the menu, or when you open, you're gonna have this options, then you go to exercise. You can go to all the reading, and I suggest you to go over the reading. Let me show you have more like description, and don't rely only on my classes. So let's take a look at this one. The manager of an automobile dealership is considering a new bonus plan designed to increase sales volume. Currently, the mean sales volume is 14. So the current sales volume is 14 automobiles per month. The manager wants to conduct a research study. So the manager doesn't know. The manager wants to conduct a research study to see whether the bonus plan increases sales volume. So increases to more than 14. Okay, does it make sense? So the manager doesn't know. So this is the challenge. Okay, currently the mean sales volume is 14. Okay, so let me come here. So the null hypothesis is that the mean is less or equal than 14. Let's go back. And the manager wants to conduct a research study to see whether the bonus plan increases sales volume. So he wants to conduct to see. That's the challenge. Let's see if it's higher than the mean. To collect data on the plan, blah, blah, blah. Develop the null and alternative. That's the null and alternative. That's what we did here, okay? Comment on the conclusion when, okay, let's keep this. I just want to focus on developing the null and alternative hypothesis. A production line operation is designed to fill cartons with laundry detergent to a mean weight of 32 ounces. A sample of carton is periodically selected and weighted to determine whether underfilling or overfulfilling is occurring. So you see, this is the key words to determine whether it's underfilling or overfulfilling. So if it is different than 32 ounces, it does not say only underfilling or only overfilling. So in this case, if you come here, we have the null hypothesis is that the mean is equal to 32. The alternative is that the mean is different than 32. Okay? We don't have the solution here, but that's the solution. Because of high production changeover time and cost, the director of manufacturing must convince management that the proposed manufacturing method reduces cost before the new method can be implemented. So you see, must convince management that the proposed manufacturing method, the proposed is not current, so that's something the director wants to prove, so that's the alternative hypothesis. So the proposed manufacturing method reduces, so the alternative hypothesis is about, so I could do something like, no, an alternative, I have a mean that reduces something, that's lower than something. Okay, it is here. Okay, so I could start just by writing this, and I know that the mean has to be smaller than a number. I don't know what number is yet. Let's take a look. The current production method operates with a mean cost of 220 per hour. A research study, the cost of a new research study will measure the cost of a new method over a sample production period. So I want to prove that the new method costs less. So if I want to prove that it costs less than 220, let me wait until, okay, so it's less. The only option I have here is that the current method is higher. Okay, let's take a look. Mean is higher. The proposed, this is smaller, this is what I did. Okay, so please practice, and I'm going to stop here and talk about type 1 and type 2 error in the next